Hi, I'm Randall Heyman, a university mathematics academic. Because of the coronavirus outbreak, I'm using my YouTube channel and this playlist's Corona Help in particular to help lecturers, tutors, high school and primary school teachers, parents, grandparents and students with any problems they've got with mathematics. So if you'd like me to make a video for you or your students, comment below the video or drop me an email. Okay, so interestingly, I've been recording these using Zoom, and Zoom is overloaded in Australia as I speak, so it won't let me do that. So I'm trying this time the recording that's inbuilt into Windows 10. But by the way, when Zoom's working, if at any stage you want to come on with me and we can do a joint thing, if you think that would help, I'm open to that idea. We just have to talk about it and get a time zone that works. Okay. We are now working through Euler's theorem, and I'm going to write up the sentence that we're up to. Now, R is an element of the reduced group of residues modulo m. So now what does this mean? Well, the group of residues mod m is, we would start with a set and we'd go 0, 1, 2, up to m minus 1. And because it's a group, we would normally have addition, and we would say that addition is addition modulo m. Now that's all come from this word here, group. So if you look through the previous videos I've done in this playlist, actually just a few days ago, I did a couple on groups. So a group has got a set here, and it's also got an operation, and a group has some special properties. So this is a bit confusing because it says the reduced group. So what are we going to reduce this? How are we going to reduce it? So this is wrong. So because we're talking modulo, you remember we had the Euler totient function where I said it was all the elements that are co-prime to m. So instead of having this up here with all of them, what we'd have is, let's call it x, such that 1 is less than x is less than m, and that the GCD of x and m is equal to 1. So that's the set. So example up here, m equals 6, which I think we did before. So this set that I'm creating would just be the set of 1 and 5, because they're the only ones that are co-prime to 6. The only ones with a GCD of 1 with 6. Okay, so that's fine. But then what if you have actually looked at my videos on groups? You can say, okay, fine, form the group. Groups have addition. And now we've got a problem, because if you go to here, well, I understand it's modulo m, but if I go 1 plus 1, well, 1 plus 1 is 2, and 2 is not in the group. So we haven't got closure under addition. So something's wrong here. And it's a little trick. And the trick is that we don't do addition. Normally for groups it's addition, and then when we go to rings we add multiplication. But in this case it's multiplication. So that's a real trap to beginners. So multiplication is just multiplication. Modulo, in this case it'll be a modulo m. So if we go back up to here with our little running example, well, let's multiply these. 1 times 1 equals 1, 1 times 5 equals 1, is 5, and 5 times 5, well, it equals 25. But remember, we're in modulo 6. Here's the 6. So that is equivalent to 1 modulo 6. So what we're saying is 5 times 5 is 1, and 1 is actually in the group, so we've got closure. And in fact, what this is saying is that the inverse of 5 is actually 5 itself. If you multiply 5 by itself, you get 1, so the inverse of 5 is 5. So all of these elements in here, in this set that I'm creating here, they're all invertible. They've all got an inverse. Okay, so let's just clean this up a little bit. Whoops. I don't want that. I don't need that. I don't need that. Just want to make sure that we understand what we're saying here. Okay. So what this is saying is that R is an element of this group. And the previous line that we had, I'll just read out the previous line. First, A is equivalent to R. Yeah, so what it had up here, I'll write it in blue, just in point form. It said A is equivalent to R mod M, and the GCD of Rm equals 1. So because the GCD is equal to 1, it means R's got an inverse. This R here has got an inverse. So it's certainly, R is certainly here, it's certainly between 1 and M, certainly got a GCD equal to 1, and as I said, the group structure involves multiplication modulo M. So I hope that's helped you with that sentence. If you've got any comments on this, comment below the video, or questions if you've got, and you can also email me at this address here.